Welcome back to the shop today, everybody. Today I'm going to start on a project that I've been wanting to do for a while. Ever since I built our CNC plasma cutter, I have been really into this, and the fact that I was able to make this work sparked a lot of imagination and creativity in me, and I want more CNC machines. So we're going to start on a CNC router. So one of my goals with this machine was to use what I had, very budget friendly, but also set myself up in a way that if I want to upgrade it later, I could. This is also the first project that I have been doing from design all the way to build. So I attacked this a little differently. With our CNC plasma cutter, I just had that all up here and I kind of just went for it. A couple of doodles and some paper here and there and kind of just went for it. But in doing so, I made a few, I'm not going to say mistakes. There's things that I would change, and mistakes. Yeah, there was mistakes. But there's some things that I would have done differently knowing what I know now. And with my education that I've given myself through CAD, I use Fusion 360 for a lot of stuff. I do that for a lot of my sign creation and parts and stuff like that. But I've never made full assemblies and turned it into a machine. So it was kind of cool to draft this all up. If I can remember, I'll throw a picture of the model up right now to kind of see what I'm going after. You'll notice that this machine is going to look very similar to some other ones out there. I forget which one it's called, but not NP CNC. It's one of those. It's very popular. Print NC, that might be it. But they do something similar. I took some design cues from there, but I put my own spin on it, and I went with stuff that I liked about my plasma machine and stuff that I didn't, and made changes to handle the side load and different things like that. Because if you remember back in my old video of when I started working on the plasma machine, I planned on putting a router head on there. That was my plan, but the gantry just ended up being too weak and a lot of slop, so it just wouldn't have worked. So we're going to go a lot more rigid with this guy. What we're starting with is some 2x4" square tubing, aluminum. I think this is quarter wall. Whoop. Gonna drop it here. Yeah, quarter wall, nice heavy stuff. The only reason I'm using aluminum is because I had it. I have a lot of this stuff. These are all cutoffs that I got from a guy. He was making trailers back in the day. He sold his company or just stopped doing trailers, and I paid $400 and I cleaned out a shop of all his aluminum and pieces and scrap and stuff like that that were usable. Good investment on my part. A lot of good stuff in here. So anywho, I have these nice 48" long cutoffs of square tubing, so that's what I'm going to use. I probably would have used steel because it would have been cheaper to buy. So if you're going to do this yourself, I would purchase steel. Plus the weight is always good. I might end up filling these with sand or something like that to weigh it down even more, but that's getting ahead of ourselves. Let's make something that works first. And beside it, this is going to be the side rail. One thing I really liked about my CNC plasma, which a lot of people said wasn't going to work. Now I know there's a lot of people out there who have done this. Maybe not a lot. Maybe there's only a few of us stupid people left. But I did the V bearings on angle iron. Now this has been working great. I do not have much complaint about it. How I set it up, I do. I should have done the tension differently. But as far as angle iron with V bearings rolling on them, I have had great success and very minimal complaints on that. So I'm going to try that again. Only difference is instead of using angle iron, I have a plate. So this plate will get bolted up to the side of this guy. Let's see if I can show this to you. And it overhangs a little bit on each side. So I have my bearings to go. I might even chamfer these guys. I got one of these cheap beveling tools. I might run this across there just to give it more of a, how would I say that? More of a edge to it for the V bearings to run on a little bit better. but we're gonna see how that goes. I did design this with in mind that if this just doesn't work, I have enough room on the top of these rails to run linear rails. So if worse comes to worse, I'm trying to do it on the cheap because I still have V-bearings from my first project. Got all this stuff, and I really like that design, so that's what I'm running with for right now. Go ahead and judge me if you want to. That's what I'm gonna try doing. And some of the store-bought ones, they have those rubber V-bearings, but they're not V'd like this. They're just coned, and they run in the crevices of extrusion. And if people are trusting that, I think I can trust a steel V-bearing on a piece of steel, or at least for a short period of time. So I'm gonna give that a whirl. And I've kind of been introducing a few other ideas. And again, this is all stuff I've learned from either listening to people, watching people, or coming up with my own ideas. And since I needed to have holes placed in certain positions on these tubes, I have the 2 side rail tubes, which are what these are, and I needed them to be mirrored, and I needed to drill those holes in all the same spots. Another thing that I kind of failed at with this unit is all these bolts and everything holding this kind of stuff together. This was all done with a caliper, with a hand drill press, and I was able to accomplish a lot by just using a caliper, but to get stuff to be the same on each side is tough. It's not an accurate process. Now, I don't know how accurate the process I used here is, but what I did is I used my 3D printer and I printed some templates. Very simple templates. So all I did, so now I make that guy go on there. It has ledges on all 3 sides, and I can use a center punch my holes. And then I can go to the other side and do the same thing. I did that over here. I have this for the other side. So it's kind of a really neat process. It allowed me to put all these holes where I needed them. So hopefully, as long as my 3D printer is somewhat accurate, I bet this is more accurate than me scribing lines with a caliper. So I did not cut this myself on my plasma. These are actually too long for me. Plus at where my place of work has a nice laser cutter, so I had them make these for me, just so I knew that they were straighter than what I can do. And plus I could get the length I wanted. So anyways, I'm gonna drill up the rest of these and we'll start assembling. The idea of this video is to get the base made. It's gonna be in a couple of different videos, so I will warn you now. But let's try to get the base of this CNC made. So now that I have everything pilot hole drilled, I'm gonna start by mounting the side rails, and I kind of already started here. So what I did is I just drilled out these holes and I tapped them. It's another reason for using thick material. I can actually tap into this and I don't need nuts on the backside. So I got these, and this is kind of how I designed to do it. Like I said, I had those 3D printed pieces that marked out these holes for me, but the rest of this plate, obviously I'm not going to 3D print something that does them all. I mean, I guess I could have, but that's kind of ridiculous. So I just made sure I had the ends where I wanted them. Now I did need to drill these holes out a little bit. On this end, they're a little bit wrong, but we'll see if we can get away with that. So anyway, so I drilled and tapped these guys, and now I have my template to do all of my other bolts. So I'm gonna spot drill, or kind of mark drill these guys, and then go at these guys and tap them, and then this side's ready, and I'll do the same to the other side, and we'll keep going. So the side plates are on, and I marked and drilled and tapped all those holes. There might be a broken tap in here somewhere, but you'll never know because I didn't film it, so it didn't happen. But anywho, now my next project is there's gonna be end plates that kind of bolt onto here. It's kind of hard in this orientation to believe or understand, but there's gonna be a plate here. There's also gonna be cross beams that run across to connect these two in parallel. And so to mount those guys, I need to have a mounting surface here to bolt a plate onto. And to do that, I cut these pieces of angle iron. This is really hefty, like 3/8 thick aluminum angle iron. I think it's 2-inch. And so I'm gonna put these guys in there like so. Got to grind them up a little bit. And I'm gonna drill and tap, or I'm just gonna drill these holes and tap this guy and bolt that on. And there's gonna be 2. I gotta cut these down. There's gonna be one on this side and one on this side. And so what that's gonna allow me to do is create bolt holes on this side to have a plate. I hope that kind of makes sense. I know I'm explaining it badly, but once I kind of get it together, you'll know what I mean. And to mark the holes on this guy, we're gonna do the same thing. I have a 3D printed piece here that mimics these two holes right here. And then also it mimics the hole on the front, which matches our plate. So this guy just goes in like so. Sits in there like that. And now I can center punch my holes. And then I have them all marked. Drill, tap. And Bob's your uncle. Or Frank. Or Tom. I don't know what your uncle's name is. But anywho, so now I got to do that 8 times because I need 2 for each corner. And I actually have to make some more of these because it's the same way I'm holding the gantry on too. So anyway, I guess I should mention that this thing is 99.9% bolt together. Like I don't plan on welding this thing together unless it shows that I need it. So we'll see how it goes. But it'll all make more sense as we go. So I'm going to get those corner pieces made up, bolted in, and then I'll show you those as well. So I quickly did one up so you can kind of get a better idea instead of me trying to explain it. So we have these 2 bolts here that are now holding in this piece right here. And then I have a center punch there where I will drill top another hole for a plate that's mounting on top of here. Makes it a nice clean fit. I guess my measurements were pretty close because it's pretty flush enough for what I'm doing anyways. One mistake I did make is this bolt. Oh, I guess it does clear actually. So technically this does clear. I thought of that, but I've been known to make dumb decisions from time to time. So anywho, that's what I'm doing, and I'm going to have 4 for each one. So 1, 2, 3, 4, 5, 6, 7, 8. So I have a lot of drilling and tapping to do, especially because I broke my nice tap. So now I have to use my crappy old one, which I guess hasn't failed. So that must be my good one, or it is my good one now. I'll get all those tapped up, bolted in, and then we'll work on the cross beams that hold both sides together. And then we'll actually start seeing what this thing's going to look like. So I kind of got ahead of myself a little bit. It's been a day or so since we were talking last. But anyway, I actually went ahead and put the cross braces on because I wanted to get this thing kind of somewhat together. So what we have here, don't mind the tools. So these are our cross beams. I also moved it from the table to here, a little easier to work on here. And I got our side plates all mounted up here. So these things are also acting as nuts from the downside, from the upside. So there's those guys. I'm going to put a third one in there, possibly if I need it. I'm also going to cut these guys diagonal so that way the bearings have room because the bearings will contact here. I did have that in my designs. I just haven't got around to cutting it yet. But got both sides on. So this is kind of the size we're working with here. I think it's around, I think it's just shy of 48 and around 30 wide, give or take. Well, I guess we can get a tape measure. We could do that. So, yeah, we're just on 4 feet there, so 48 inches. And we are on the inside to inside, 27 and a quarter. It's not quite 30. But that's just what the ball screws I had would allow. And plus, this thing is looking big. I didn't expect it to be this big. Sorry about that. Yeah, I didn't expect it to be this big. But it is what it is now. So we're going to do it. I don't think I'll ever need something this big, but I also said the same thing about our plasma table, and now I wish I built it bigger, so we'll see how that goes. So, and I have plates for the ends that I got to get on, which are these guys right here. So what these are going to allow me to do is these will bolt right here like so, kind of tie everything together. And the hole that I'm going to drill here and tap is going to hold these guys on. And then this is also acting as my mount for my NEMA motor. So that motor will mount off the ends. And ball screws will run on the outside. And like I said, more of this will make sense as we go. And I actually might recut these plates because, oh, my phone's doing something weird. I might recut these plates because now that I have my machine torch on my machine, that thing works a lot better. So I might recut them. I also did it at a 1/4 inch. I don't know if that was truly necessary because it's pretty thick stuff, and this is really just supporting a small motor, so I might be able to get away with like 7 or 10 gauge. But I have those, so I might try them first. So I'm gonna get those mounted, finish up some of this tedious stuff. I'm not gonna film any of that because that's just boring. Because it's just gonna be me cutting and tapping and drilling and all that kind of stuff. So I'll get this thing kind of finished, the base, and then we can go from there. Also, you might have seen this guy. This is the side mount plates. I just have it kind of barely on here because I need to figure out my adjustment screws, and we'll explain that more on another video. But these are the side plates. We're gonna have the V-bearings running on there. I will put a bevel on these, don't worry. And again, my knee motor will hang off the side, ball screw along the back, and these 2 bolts will hold another piece of square tubing. Again, it'll all really start making sense once I get more finished. But for right now, I'm just gonna get this base finished up so we can end this video and start on the next one. Well, I think I have the base as far as I wanna take it for this video. So as you can kind of tell, we are working with our corner pieces here. So those corner pieces kind of keep everything attached in the corners. I have 1 crossbar there. That actually isn't solid yet. Because I'm not sure if I want 1 or 2 in spread across here. I don't know if that'll play a part, so I'll have to make up my mind there. I threw a chamfer on these pieces. Well, this one, I don't think I've done that one, but again, I'm just trying to get something together here. I used this chamfering tool here. Now, these were good, but this is too much for this thing. I would not recommend this for such a deep bevel, but if you're cheap like me, this was $14 on Temu. I'll buy a few of those to get this bevel done instead of me spending a $400 machining bill to have somebody mill that up for me. So to each their own. Anywho, that's done. I got my ball screws mounted, and I even have a motor mocked up here so you can kind of tell what's going on. This is the back of the machine. So the motors will hang off the back. And this will move our gantry. And our front plates are literally just blank. And these do nothing but look pretty and bolt these corners together because these are also bolted up from underneath. So I'm calling the base done. I think it's done. I need to, again, drill some more holes. I need to mount this guy, or if I need to mount 2 of these crossbars, and I need a chamfer this side. But other than that, this is done. So I will finish that up off camera because there's no point in you guys watching me do that. So the base is done. That's exciting because that means we can move on. I think I'm gonna recut. I did cut my gantry side plates, the plates that come upright on each side. But that was before I had the machine torch on my plasma cutter. So with the machine torch, I'd like to cut them again. That one just cuts way nicer. And I noticed that with these plates, my holes were a mess. So might use some washers to cover up some holes. I mean, it's my machine. I'm not too worried about it, but just plasma's not the most accurate thing in the world anyway. And now you mix that with a bad torch setup. Nothing aligned the way I'd like it to. So anyway, guys, thanks for stopping by. I really appreciate you watching. If you could subscribe and like this video, I'd appreciate that too. Or at least consider it. And we'll see you on the next one. See ya.